Hi everybody. My lecture today with the title High Performance of EMG Signal Sensor and Effect on the Accuracy of Artificial Limbs Implementation. I am a Prof. Dr. Yousif Al Mashhadany from University of Anbar in Iraq. Uh, Simple introduction for myself. I am research and control engineering topics. I have research focusing with the biomedical engineering and robotic system. I have 81 research work published with 44 journal papers with the Scopus and the Clarivate, and I have H index 9. I have three books and 32 conference and two chapters. Uh, I am ready to cooperation with anybody and my information in the slide with my phone with WhatsApp application and my email. The outline of my literature with the three main headline EMG signal identification and classification system. In this topics will discuss the definition of EMG signal, physiology of EMG signal and the EMG signal characteristic, measurement of EMG signal, modeling of EMG and simulation. Then we'll discuss about detection of EMG signal and recognition of human arm movement. And with this talks, we'll discuss the recognition of a human arm movement by EMG signal, forward and inverse kinematics of a human arm that is requirement for controlled with the human arm movement. And the third headline is the EMG signal effect on the accuracy of artificial limbs. Therefore, we'll discuss about type of artificial limbs and the artificial limbs based on EMG case study. Abstract will discuss three main topics: anatomy of EMG signal identification and classification. EMG signal is the stochastic random signal and will define this signal. Therefore, the real measurement of this signal very difficult because this signal changing with time and with the muscles and according to the position of the EMG electrode will get different amplitude and period and number of turn and like that from the features of this signal. Therefore, the two steps identification and the classification for the signal is very difficult. We'll discuss this in detail in the next slide. Also, we'll discuss the detection of the EMG signal recognition of a human arm because Allah subhanahu wa ta'ala created the skeleton of a human body and every joint in this skeleton controlled by muscles. These muscles constructing and relaxation by the instruction from the brain. This instruction transfer through the nerve from the brain to the muscles. Therefore, the recognition of the human arm and its movement based EMG signal is very difficult system. And I have about um, 20 papers published discuss this situation. Finally, EMG signal effect on the accuracy of artificial limbs implementation. This is very important in the application of the artificial limbs because the mean controlled for the artificial limbs and the accuracy of the movement and the synchronize between the artificial limbs movement and the human limbs movement is the accuracy of the measurement for the EMG signal because with the getting of the high accuracy for features like that, the amplitude and period, because this features, two features, is the very important with the application of the artificial limbs. Therefore, when the measurement of the EMG signal with high accuracy, that means we'll get artificial limbs with high accuracy implementation. And therefore, the title of the my literature, high performance of the EMG signal sensors and effect on the accuracy of the artificial limbs. Therefore, we'll discuss two side how get the high accuracy for the measurement of the EMG signal, and how this EMG signal will affect on the accuracy of the artificial limbs. EMG signal we defined as the biomedical signals that measured from the electrical current with the level of the millivolt and millisecond during the construction of the human muscles. Human muscles construct from the motor unit and plasmas and the fiber. Therefore, every motor unit has a cross-section area and the diameter. The signals for the construct and relaxation for these muscles transfer from the brain to the muscle through the nerve. Like these signals will transfer from the axon hair and transfer through this axon basic neural process. This the synthesis of the nerve cell. Therefore, the signal from the synthesis will summing at the body of the cell and then transfer the signal after they get the threshold through the axon of the cell, nerve cell to the next cell. And this procedure will transfer from the instruction transfer from the brain to the muscle. Uh, physiology of EMG signal, this chart for this brain will transfer the signal from the nerve until the muscles. This muscles for the biceps, this muscles is controlled for the elbow joint. Therefore, when get move the elbow joint, will construct the biceps muscles. The measurement of the signal to get from the skin to the electrode by measurement the different voltage between the two electrode, and then will apply signal processing, filtration, and the amplification. The two main process for the real measurement is the filter and the amplification. This the nerve, this the electrical signal will transfer to skin and to get the sensing from the electrode. EMG signal characteristic. EMG signal has 16 characteristic, and the main effect in the artificial limbs application is the amplitude and the duration, and sometime rise time and phase maybe sometime get application in the special case for the artificial limbs, but the all the artificial limbs for the high two limbs, the upper or lower limbs, can control by the amplitude and the duration for this signal, because from the amplitude can be calibrated with the moving of the joint, and then with the number cycle of the motors that is controlled with the joint. The EMG signal, when I loading the and apply construction for the muscles, will get the signal with millivolt and millisecond, but this signal is the randomly signal. Therefore, we'll apply capturing with the same this form to recognize EMG signal. Measurement of EMG signal at reals start with the electrode, and we have two type of electrode, needle and surface electrode, and we'll discuss in the next slide. The second stage is the after well sensing the signals from the electrode or needle will enter to the second stage is the amplifier and filter signal. We used low pass filter and band reject filter to filter the dizzy noise and Gaussian noise, and amplifier. Sometimes this amplifier will reach until 10,000 because this signal is the millivolt signal. After that, will enter to the software in the PC using the interface card and apply the analysis in the software, and we'll discuss the software by the EMG lab. Modeling of the EMG signal and the simulation is very important in the work of the artificial limbs because we must test the EMG signal from the patient. Therefore, after the before the measurement, we can apply simulation for this signal. The modeling of the EMG signal is very important, and the modeling is depend on the four main parameters. This is the parameter is the number of motor unit in muscle and the diameter of the motor unit and the muscle fiber cross section area and the muscle fiber density. When select certain value for this parameters, will get by using the equation for the connection this four parameters will get the form of the EMG signal by the using the grapher user interface for the EMG, and the amplitude of the EMG signal is dependent on the for value of the forming part and the position of the electrode on the skin in these muscles. Therefore, when different using measure with the different position of the electrode, we will not will get different amplitude, and also according to the value of the four parameters will get also a different value of the amplitude. All this option can discussed by using the EMG simulator. Allah subhanahu wa ta'ala created the human body with around 650 skeletal muscles. All these muscles controlled by the human body, especially in the artificial, in the upper and lower limbs, two arms and two legs, we can recognize this muscles that is controlled the joint, like that for the muscles, biceps muscles controlled by the elbow joint, and the deltoid muscles controlled with the shoulder joint, and like that. This is the GUI of the EMG simulator. When we put a certain value for the number of motor unit in muscle and muscles fiber density and the muscles fiber area cross section area and the motor unit diameter, and select the number of the electrode and certain position, will get the EMG signal. Simulation of the EMG and analysis can be done by using the GUI of the EMG lab. This is the grapher user interface under the MATLAB package. By using the EMG lab GUI, we can apply full analysis for the EMG signal and get the features that we need to apply the control for the artificial limbs. By using the EMG lab, we can get a number of turn, amplitude, duration, and like that. And we can apply full analysis for this signal. The real measurement of the EMG signal, we say at the previous slide that start with the electrode, and we have two type of electrode, a needle electrode, and this in the last time before the 2009 we used this type of the electrode, especially in Iraq. We in this time we don't have surface electrode, and when I apply the PhD study, I used the needle, but this needle cannot used in the artificial limbs. This is especially used for the recognition the muscle disease. Because we have the two main type of the disease in the muscles, myo disease and neuro disease. And I have two or three papers published papers discussed for the muscle disease, and I apply this practical recognition by using the needle electrode. But in artificial limbs, we must use the surface electrode, and we'll fix this electrode inside the artificial limbs to detect from the skin of the muscles the features for the EMG signal, and use these features to control the movement of the joint. In this slide, we can recognize five type of the electrode surface, and all this surface work with the same technology by measurement the voltage difference between the two electrode. We all the surface electrode, we used three electrode. The first one is the ground, and the second and the three is the two electrode with positive and negative voltage to measurement the different and recognize the EMG signal. Every one from these muscles has a specification for the different. Maybe the second type 2 is the very high accuracy because used two type of the filter and used the amplification with around 10,000. The type surface electrode type 5, very important with the application of the artificial limbs when we used measurement many signal at the same time. Now in the type of 5 we used the measurement of the four muscles, two fixer and two extensor. These muscles controlled by hand, five finger and wrist joint. Therefore, this is very important type of electrode when we dealing with the hand of the human, because this electrode used to measurement six EMG signal at the same time. We also the electrode or the measurement system for this is 8 channel, and this used for the apply the measurement and decision about some disease in the muscles of the human body, like foot drop disease or like this disease. Therefore we must use measurement with the many muscles, sometimes 8 muscles. Therefore, this system for the analysis of the EMG, not for application of the artificial limbs. The neural network identification uh, used in my work, and I have around 20 papers published with this. We can explain in this the flowchart. We have two sources of the EMG. Sometimes I use the EMG generated from simulator, and sometimes from the real EMG measurement. With the same two source will filter of the EMG and then amplification, and then apply a normalization of the EMG signal to used with the uh, neural network identifier. The normalization with this equation and the structure of the neural network I used to the recognition is the finite recurrent backpropagation, and I used the 1600 sample from this signal to apply the identification, and with the learning rate about 0.01 and the momentum term with 0.015, and I acceptable the error or mean square error with the 0.005. Therefore, we can recognize the two-stage signal processing part and the identification part. After the identification, I can apply the classification between the EMG muscle, normal EMG muscles, or random and rubbish. This is cannot apply with the artificial limbs. Therefore, I will classification two type of signal: normal signal and abnormal signal by using the forward classification by used finite for recurrent neural network with the bug propagation with momentum term learning algorithm. And the recognition of the human arm movement by using the EMG signal with the for recurrent bug propagation network also can implement. And I apply the many study with the two human arm, right and left, with the 7 main muscles: triceps and biceps, and deltoid. Triceps, biceps by using controlled with the elbow signal, elbow joint, and deltoid with the shoulder joint, and the extensor, two extensor, cabral radial and allo, and also two flexor muscles with the cabral radial and allo. This is the 4, 5, 6, 7 muscles, extensor and flexor. This is controlled by the fingers and the wrist joint. This video for the real
هنا
measurement
عضلة البايسبس هذا
this
ربطناه
by
نسوي له
biceps,
كينوت.
and this measurement by using Arduino microcontroller, and when apply the construction of the biceps muscles will get the movement of the elbow joint and this muscles for the biceps signal, and also can recognize the twist for the elbow by using the triceps. But now with this the measurement of the biceps and show the control for the elbow joint. There. Now this presentation for the every muscles in the human body controlled by the joint, like this deltoid. Now this deltoid muscles controlled by the shoulder joint, and other the biceps and the triceps controlled by the twisting and the abduction and adduction of the elbow joint, and you can recognize all the human body muscles by the using the link of the YouTube, and you can very useful video, because this every muscles in the human body will learning how to control by the joint. When I apply the artificial limbs, we must know how the real human arm working, and how the controlled for this movement. Uh, Allah subhanahu wa ta'ala created the human arm with the redundancy system, because the movement of the human arm system has the number of input more than number of output. Therefore, this is the redundancy system. Therefore, we must learning how apply forward kinematics and inverse kinematics of the human arm. I have many paper published with this, because I solving the inverse kinematics with the analytical solution of the inverse kinematics with the full order system by using solving the elbow joint. I applied the name theta 4 and solving this for the elbow joint through the phi, and will get the movement of the joint, elbow joint, as the ellipse cone. Therefore, also we can analytical solution with the reduced order system by cancel 1 degree from the elbow joint. This can done by transfer the twist movement from the elbow joint to the wrist joint, and therefore in this time we'll get the same number of degree of freedom, because the human arm has 7 degree of freedom, and therefore we have in this two solution for the inverse kinematics, and also for the forward kinematics. After the learning of the kinematics, we can apply the movement of the artificial limbs accordingly for symmetric with the real human arm. The solving of the forward and reverse kinematics depend on the DH parameter. Therefore, when apply this posture for the human arm, 3 degree in the shoulder, 1 degree in the elbow, and 3 degree in the wrist, will get this DH parameter, and then will apply the solving of the inverse kinematics. Now, the artificial limbs implementation, how I can manufacturing full successful artificial limbs, what the condition must available in artificial limbs to say this is the successful artificial limbs or optimal artificial limbs. The artificial limbs, it must have has shape similar the human limbs as possible as can, because this is very important. Working of the same technique with the human limbs with the EMG signal to get the full synchronous between the two arms. Also, the weight of the artificial limbs must be same or less than human limbs. Also, the movement must be controlled by the brain and get the same accuracy with the same time of the human limbs. Also, it has the ability to carry the weight and coupling the same value with the real human arm to apply the patient with the same movement and the same accuracy. Type of the artificial limbs according to the part of the human body losses, we apply the category of the artificial limbs. Therefore, when the missing of the hand under the elbow joint, that means with the transverse limbs, when they lost from the shoulder joint, therefore this is the transhumeral hypothesis. When the leg under the knee, that means transitable hypothesis. When they lost from the all the lag, that means is the transformal hypothesis. Therefore, we have four main parts. But according to the technology applied in the artificial limbs, we can recognize two main type of the limbs, artificial limbs. A cable operating, that means the artificial limbs apply the movement by the cable. When I move the cable withdraw, that means will control for the movement of the artificial limbs. The second type is the myoelectric hypothesis, and this I discussed in this literature, because this type of the artificial limbs is the depend on the working by using EMG signal and then transfer the signal measurement by electrode, and then retreatment by using the microcontroller, and will transfer to the motor. DC motor will apply the movement of the artificial limbs. Now, this is video for the implement of the project. I apply this project. Now we showed this patient loses his hand and apply the manufacturing of this hand. Firstly, we must test how, if this muscles of the patient can apply movement of the stepper motor. When successful to movement of the stepper motor, that means will successful for apply the artificial limbs. Now we manufacturing the artificial limbs, and now this limbs will enter, this muscles will enter inside this hole, and can control by this movement of the finger, and dependent on the number of stepper motor, we can recognize the movement of the five fingers at the same time, or the separately fingers by fingers, and also we can control to the wrist joint. The accuracy of the implement of this movement depend on the accuracy of the measurement of the EMG signal. Therefore, we can say the mean conclusion of this literature: the accuracy of the executing order in the artificial limbs depend on the accuracy of the measurement EMG, and also the obtain the full synchronous between the movement of the real human arm and artificial arms depend on the accuracy of the calibration of the amplitude of the EMG signal with the movement of the stepper motor according to the movement of the joint. Therefore, will transfer the amplitude of the EMG signal with the millivolt to the movement of the motor. Also, the uh, recognize between the movement of the human arm, we dependent on the distinguish of the EMG signal that is get from the instruction of the brain through the muscle. The most important effect of the EMG signal is the DC noise and the Gaussian noise, and we can cancel this noise to get high performance of the measurement of the EMG signal by using the filtration and the amplification stage. Thank you very much, and I am ready to any question. Also, if cannot get chance to discuss through the presentation, we can contact with me by email or by phone with WhatsApp application to discuss. Thank you very much, and I hope meeting in the next time with the other conference. Thank you. Goodbye.